Bem-vindos to one more episode of the Type Theory for All podcast. As always, this is your host, Pedro Abreu, and in this episode, we go into a deep dive into formal methods side of voting systems. For this, nobody better than our guest, Joe Kiniry. He is a principal scientist at Galois, principal CEO and chief scientist of Free and Fair, which is a Galois spin-out focused on high assurance selection technologies and services. For the past 20 years, Joe has worked tirelessly in designing, developing, supporting, and auditing all kinds of voting systems for different private parties and government parties. This interview is absolutely amazing, and I am very confident that you guys will love it. Before getting into it though, let's hear a quick word of our sponsor. This podcast is made possible thanks to our sponsor, FormalLand. FormalLand is a formal verification company focused on verifying the implementation of programs with the cockproof assistant. They have been working on the verification of Rust and OCaml code for the blockchain industry, in particular for Tezos and Aleph Zero. So if you're looking to ensure an extra layer of correctness to your blockchain, you should take a look on FormalLand's work. All right, welcome everyone to one more episode of the Type Theory for All podcast. As always, this is your host, Pedro Abreu, and I'm speaking directly from Brazil. With me, we have our co-host, the one and only Dan Plokin, which I continue to get the name right, and I'm very proud of myself. How are you, Dan?
Yeah, which is funny because, after there have been several episodes where I've given you a lot of crap for the way you pronounce my last name. We realized recently I did not know how to pronounce your last name at all. I believe it's Pedro. Now we're going to do a series where I continually mispronounce your name. Pedro Abreu? Abreu?
Yeah, that was really good. That was very good. I'm proud of you, man. Thank you. Thank you.
Thank you so much. Yeah, and I'm calling from Denmark, and I forgot to pack my XLR cable, so I'm sounding I'm going to be the kind of distorted guest with like fans and cats meowing and banging on the desk and giving people a whole bunch of work to edit.
But you're comfortable and you're having a good time in Copenhagen. That's the most important part.
Yeah, it's you can't complain. Yeah, it's pretty good.
That is awesome because that we are all about comfort. I hope. So our guest today is Joe Kiniry. Welcome to the show, Joe. Did I butcher your name? Was it
No, you actually got it right. So I'm proud of you, Pedro.
I just noticed that I usually always ask my guests, like how should I pronounce your name? How exactly do you want me to do this? And today we're just so worried about so many microphones here and there that I just forgot. How are you, Joe? Welcome to the show.
I'm fine. I'm fine. It's nice to finally get together and have a chat.
It took a little bit of coordination to make this happen, but I'm happy that we're here.
Yeah. Well, my colleagues at the office say the same thing.
That's the thing about being such an important person as yourself. So, Joe, tell me, let's start from the beginning. Let's go back from when, we are starting to think about how electronic voting is coming about. And if you are able to tell us a little bit about the history of voting, of paper ballots, and where did this idea of making our voting electronic and, trying to make it as secure as possible came to be?
Sure. I can give you a big picture perspective on that front. I will say that if a listener is really interested in getting a background on this topic, there's an excellent book that's easily available on Amazon and whatnot that helps out. It's called Broken Ballots, and it's written by a couple of colleagues of mine, Doug and Barbara. And it represents a really excellent snapshot of the history of voting, both with mechanical and digital means over the past 100 years or so, and the introduction of paper ballots, the introduction of private Australian-style elections, and more. Big picture, people have been voting for a long time, but maybe not as long as you would think. I mean, it does go back, of course, all the way to the Greeks and whatnot. But in the modern age, the idea of voting in the way that we do in a modern age, especially with pieces of paper, doesn't go as far back as you might think. In fact, there is great dispute around whether or not voting should have physical manifestation of any kind, whether or not mechanical means were involved, whether or not you should have privacy with regards to your vote. Most of the early voting, both in Europe and the United States, for example, not to take a Western perspective, involved walking into a room and sticking your hands up in the air. That's the kind of thing that we used to do. And it was only with the wide-scale adoption of the Australian secret ballot that we started to decouple and introduce notions of privacy and decouple a voter from their vote, which introduced a whole new range of exciting opportunities and challenges, at least from the perspective of a security perspective on elections. Even in the modern age, people vote in all kinds of different ways with pieces of paper. You don't always have a piece of paper and you mark on it. Sometimes you're handed, for example, a bunch of different pieces of paper and you stick one of those pieces of paper into a ballot box. Ballot boxes have different shapes and natures. Some of them are clear and some of them are opaque, for example, is one of the biggest disputes around ballot boxes. How they're locked, whether or not they're in administrative control and the like, is another big thing that varies significantly from place to place. And then the introduction of mechanical means, initially with electrical mechanical systems like clockworks to help one vote, and eventually the introduction of digital technology back around 50 years ago is the first time that kind of happened widespread. So we've seen a big arc of how people vote in terms of how do they put in their choice when it comes to either voting for a candidate or a referenda. The other thing that's evolved over time is the electoral schemes involved. How do you tabulate? So how do you turn voter input into an outcome? Here in America and in a couple other places in the world, we have kind of the worst possible scheme, which is plurality voting. If you get 50% of the vote plus one extra vote, then you win. Leads to all kinds of troublesome outcomes in a split bifurcated electorate of two sides hating each other, it seems. Around the world, people use many other schemes that are called things like ranked choice voting or IRV or proportional representation with single transferable vote. So there's a number of other electoral schemes which really boil down to an algorithm that tells you how to take your votes and determine an outcome. So I happen to have worked on a number of those different schemes over the years because I've been a professor all over the world. And every country I go to has a different scheme. So I've had to learn about all those different kinds of ways that one can run an election and thus how one can, for example, tabulate and audit an election. And the interesting thing about those schemes is that you would think that counting votes in a plurality scheme like we do in America is straightforward. You would think that the math is simple. And it is if you think about it just from an arithmetic perspective. But almost every tabulator I've ever looked at is wrong, which is kind of remarkable and gets you into the geek weeds on matters of verification and similar. And that's especially true if you look at every single tabulator I've ever looked at for a non-plurality scheme. The description of the math necessary to count votes in Ireland, for example, is like dozens of pages of legal text written by non-experts and non-mathematicians. So as to turn that legal specification into a mathematical specification was an entire PhD thesis and ended up opening up all kinds of worms there.
What about like the tabulator for the plurality thing? Is that something that you can describe the flaw in a podcast form? Is it that simple, or is it like, what even is a tabulator, I guess?
Well, so a tabulator, so if you think about it, regardless of how you vote, like if you vote on a piece of paper or you go into a voting booth and you pull a lever, in the end, you're capturing your intent about one or more races or propositions simultaneously. So it's a set of inputs that you're providing, not just one input in almost all jurisdictions. And when it comes to plurality voting, even though it seems simple, what you forget about is there's many races that are multi-seat elections. So you're in fact voting to appoint, say, 3 people in a jurisdiction, and yet you're only voting once. So it's not just about tabulating for a single race, a single outcome. You're tabulating multiple outcomes simultaneously because you need to find your 3 highest vote getters in that situation. But then again, in that situation, sometimes the law dictates it's not the 3 highest voters and they all have to be over a certain percentage. It's all kinds of weeds on how do you proportion out the overall scheme so that they have to exceed some threshold, which is no greater than, total number of votes divided by the number of seats or something different than that. So as soon as you open up the box and you start to look at how the statutes are written, especially for multi-seat elections. It gets hairy. And then moreover, you have many situations where you have voting happening in overlapping jurisdictions. So for example, here in Portland, we have concurrently happening county elections, city elections, and metro elections. And those are intersecting jurisdictions that overlap with each other. And so you have votes coming in at the county level, which are being contributed to outcomes at the city level or at the metro level. And so you end up with basically a distributed system that has to realize what amounts to arithmetic. It's no big deal, but there's a coordination puzzle that ends up being very hairy, that compounds that multi-seat situation and then the jurisdictional situation. So in the end, if you write down the spec for this, say in a formal language, it ends up being hairier than you think it is. It isn't like a 6-line Z spec. It's instead like several pages of alloy or caulk. And then you end up building a system that, tabulates properly with regards to those inputs. The tabulation itself, you can think of as a spreadsheet. Literally, you have what are called cast vote records, which are commonly implemented by proprietary voting machine vendors in two ways. They either output these data sets in plain text in a CSV file, which in fact is an ill-formatted CSV file because they don't account for things like non-ASCII characters and escape sequences and similar. So they're always wrong. Or it's some sort of proprietary, say, XML-based format for which you have no schema and is also wrong. So if you build a tabulator, which we have at Free and Fair, for these kinds of input formats, you have to deal with all kinds of dirty data, even though these are multi-million-dollar products that have been around for 20 years.
Mm-hmm. But when
all you're doing is taking a CSV file and turning it into an outcome.
Uh-huh. But when we're talking about like electronic voting, usually what we're thinking about is more like this, are my votes being counted or something like that? And somehow that the paper stuff is not working as well. And that's something that computer scientists are trying to solve, or?
So as soon as when I talk about electronic voting, I typically mean, and people in the community mean, using computers to help with voting in one way or shape or form. And computers have been used in all kinds of ways, independent of the voter, like the way they vote. Like tabulation is hairy. So a lot of places use computers to support tabulation only, the counting process. Or you use computers to support how to run an audit properly, for example. So there's a number of places where computers are used to facilitate the overall operation of an election that maybe are not voter facing at all. Now, electronic voting came into the fore and became a real topic of dispute in the elections integrity community right around 2000 because of the presidential election that year in Gore v. Bush, and the Supreme Court deciding they weren't going to retabulate Miami-Dade County ballots. And suddenly, and everyone was using what amounted to uncertified voting systems built with computers running things like Windows 95 all over the country. And everybody started having doubts about the veracity of the outcomes of those elections. So that's when Congress passed the Help America Vote Act in 2001 or so and started to stipulate what it meant to certify a voting machine in the field. But they focused exclusively on the computers used to sort of program the election and the computers used by voters. They didn't actually focus on many of the other aspects of elections. So electronic voting to me means computers are being used somewhere, but the way that it's like really in your face is when you walk into that voting booth or you're voting at home. And here in Oregon, it's a piece of paper and a pen. And there is no computer-based stuff for most voters. Whereas if you vote, in LA, you walk into a very fancy looking voting booth and you're using a opaque proprietary voting system built for hundreds of millions of dollars by a foreign company. And you don't have any means by which to determine whether or not your ballot is properly shaped or has the right data on it or was included in tabulation other than trusting the authorities to do the right thing.
And that sounds like a total nightmare. I mean, so why do we move away from the paper ballots? Those are good old
We don't. I mean, those of us that have been doing this for a very long time, even proper computer scientists and cryptographers and similar, always emphasize that human readable, voter facing paper ballot records are mandatory for all elections. And that's even in situations where we start to do experiments with fancy forms of voting, like end to end verifiable voting, which we can talk about in a supervised setting, or experiment around internet voting. There's still always a need for pieces of paper, because pieces of paper that voters fill out and are verifiable by the voter, that they understand everything on that piece of paper and they don't leak information about the voter or their connection to that ballot or any other inappropriate information that could be used by adversaries, is critical to having trustworthy elections. So that voting system in LA produces a piece of paper. The problem is not everything on it is human readable and is not guaranteed to a average typical voter to not leak inappropriate information, as an
I
example.
think this might be the first time I've heard a computer scientist advocate for using less computers.
Oh, God. Yeah. I mean, most of us who work in this field actually spend the bulk of our time fighting against inappropriate use of computers in elections. They have their role, but we shouldn't be diving willy-nilly into it, because elections are a nationally critical infrastructure. And you wouldn't want to just throw computers at all kinds of other nationally critical infrastructure because things go wrong. So in general, yeah, we really like pieces of paper. We really like transparency. We really like four eyes, having multiple people involved in every single workflow that represent different opposing perspectives on the situation, and only use computers wisely. In fact, that's the entire topic of my inaugural lecture when I was a professor at DTU, was where are computers useful and not useful in elections, and how do they impact sort of all the illities of an election, the security of an election, the reliability of election, the accuracy of election, and similar. It's a real perfect example of a computer science problem that involves a large number of trade-offs when it comes to the use of technology.
Do you have like a dream election? Like if money costs were no object,
Sure.
and we were trying to do maybe at the scale of a country like the United States,
Yeah.
It would all be paper. Then I guess you wouldn't need a complicated tabulation thing if it were all just a single
I mean,
candidate
if
that
we
we're voting
were
for?
only voting on a single race with a single candidate,
Yeah.
you can do all paper ballots and you can count by hand. Some places
Uh-huh.
do that. That's
Yeah.
not how elections are shaped in America. Elections
Right.
in America are like the most screwed up case study you can imagine. Because not only are you using plurality and you have multi-seat elections and you have these overlapping jurisdictions and the like, but elections are run at the jurisdiction level, and they have to conform to the rules and statutes in a compositional way at the local level, at the state level, and at the federal level. So you can have two elections running meters from each other that spread across two jurisdictions next to each other, and they can be completely different. And moreover, they can be using the same technology stack, and they paid a different amount of money for that technology, because all the dominant suppliers are proprietary corporations, for the most part owned by venture capital or private equity firms who are maximizing profits and not maximizing trust in elections. So they will charge whatever they can for every single piece of paper and equipment they sell. That's just how it is.
Yeah. So you must be like, all the pressure towards this is coming from trying to make things cheaper or make things more convenient for the government, I guess, for the ones who are running the election. And then my question.
The question initially was, what is a dream voting?
Yeah.
this
Well, I'll tell you
situation?
what the
Oh,
dream
sure.
system is. Let me tell you that. And I will say, I mean, like, we want what election, before I say what the dream system is, what elections officials want, and many but not all politicians, is maximal participation, so voters' inputs can actually be understood and tabulated, period. Almost every elections official I know that I've ever worked with in the whole world, that's what their goal is. Now, when you get to the politicians, it's a completely different can of worms. And we can get into that if you really want, but that's pretty far away from type theory for all. But I can tackle it from an objective scientific standpoint. And so what we want is for people to participate and for them to have trust that the outcome of election is in alignment with the input from the voters. What we have is, here in the USA especially, a smattering of different voting schemes, voting styles, election schemes, and different kinds of computers and pieces of paper and everything else. That means it's a giant, huge ball of mud, frankly, with very little weak oversight at the state and federal level, because there are powers out there that don't want things to be more correct and trustworthy. They want to fight tooth and nail against having stronger certification standards. It took us something like 15 years to get new certification standards that mentioned anything about more rigorous means of correctness or security at the federal level, for example. And then when it did get done, it was done by a bunch of volunteers, myself included, working together to write the new standards, because no one would pay a dime to help out with it. So it's just a big honking mess. I'll try not to use 4-letter words. So for those of us that have been constructive about these topics, because there are folks both in the traditional elections community, like elections officials and activists, as well as computer scientists, cryptographers, and more, we've been working constructively on this for some time to try to come up with a better scheme and system. And sort of the best constructive thing that was attempted was a system called Star Vote that was the brainchild of the elections official in Travis County, Texas, which is where Austin, Texas is. Her name's Dana, and she witnessed for years going to the conferences I did, smart people like, the community of folks working on elections integrity, computer scientists and the like. They witnessed a lot of stone throwing and a lot of, security evaluations and a lot of attacks and a lot of negativity. And she was like, well, God damn it, why don't we just get together a group of world-class people and design a new voting system that will work for the average US voter, that takes all the best things that we've learned from the last 25 years of research on this topic from the academic community and turn it into reality. That's exactly what Star Vote is. It's a end-to-end verifiable, supervised voting system that uses plain pieces of paper that voters can understand to run an election wherein it is end-to-end verifiable, which means you have a number of different correctness and security properties that lend themselves to trustworthiness. You have software independence, so that the system, you don't have to trust that the implementation is correct, because if it isn't, you're able to detect it by cryptographic means. And you have a facilitated means by which to do proper, statistically valid, risk-limiting audits of your outcome. So it's like everything is there. Like the first Star Vote journal paper published in the journal, I don't remember where it was published, Journal of Object Technology or something like that, a long time ago, written by a bunch of my friends and world-class cryptographers, describes that system. And that is the right thing for us to have. And in fact, Travis County created a spec of that system. They got all these people together for a couple of years. They ended up putting out an RFP to build the system. They insisted that it had to be open source and open hardware and based on COTS equipment. And a bunch of vendors submitted bids, my company included, Free and Fair, our public benefit corporation. You can read our proposal. It's online and published, because we publish all our proposals, see how much it costs, what we wrote about, and everything like that. The entire thing fell apart because the existing vendors refused to support the development of a new system, and caused the entire RFP to collapse and stopped the advancement of productive and verifiable elections into the future.
And they did this out of their own interests for
absolutely.
For the money.
Yeah. I did a FOIA request. I got everyone else's bids except for one company in particular, ES&S, who claimed trade secret on everything. Was it the secretary? Well, a government official who makes decisions about such things at the state level in in Texas agreed that with this Texas-based corporation that they shouldn't have to share anything about their bid. But in the end, it became patently clear that they intentionally, I believe, colluded with each other and killed the entire project because they didn't want it to move forward. So Star Vote, or something similar to it, is exactly the right thing that we should be using in at least the United States to have trustworthy supervised elections. And then if you have that, that gives you a beachhead for voters understanding trustworthy elections and end-to-end verifiability, which we can talk about in more detail. And then you could move towards building a high assurance internet voting system that leverages recent advancements in how you build high assurance hardware, high assurance software, proper distributed cryptographic protocols, and similar to have an end-to-end verifiable internet voting system that would only be used for low value elections. Because your attack surface is so much larger, you would never use it for a federal election. You would use it for primaries. You would use it for low value local elections, but it would provide extra accessibility for disabled voters. It would provide opportunities for potential increased participation, though there's lots of disputes about that in the long run. And it would just provide another voting channel for voters in addition to supervised voting and what we call on-paper pajama voting, so early voting like we have here in Oregon. So it's those two things together. And if you want to learn more about Star Vote, you can read the Star Vote paper. The Star Vote RFP is out there. There's a number of papers based upon the original paper doing additional analysis. Free and fair. And Galois implemented a prototype of the entire Star Vote system in 1 week using rigorous digital engineering and Haskell. Public, online, open source. We bid on the whole thing, so you can see our opinions about it in that proposal. And then if you want to learn more about end-to-end verifiable internet voting systems, my team co-wrote a whole book on that with dozens of people from the elections integrity community and the scientific community to have all their input on it. It's called The Future of Voting. It was published by the US Vote Foundation about 7 or 8 years ago. It too is open source, and it lays out all the requirements necessary, cryptographic foundations, domain engineering model, and the necessary engineering to build an internet voting system into the future. So we've already described what we should be doing. It's just next to no one will invest in doing it. And every company that's building a supervised voting system today, outside of one, and nearly every company that's building an internet voting system, outside of a couple, refuses to align themselves with any of those forward-thinking premises.
So we should definitely start to move into these technical aspects, which sound fascinating. But you gotta give us a hope for the future, right?
Yeah.
You can't just leave it there. What's the glimmering beacon?
Well, the hope for the
light?
future, there are some folks who recognize this is how we should move forward, and so the two biggest actors that have tried to move us forward and give us a hope for the future are, frankly, Microsoft and Tusk Philanthropies. Now, both of them, are entities that I have mixed feelings about because of their past work, and they both know this, and I've worked with both of them extensively. Years ago, one day Microsoft called me up and said, how would you feel about designing and building a software developer's kit for all the existing vendors to provide them with end-to-end verifiability so that they could take their existing product and add this extra cryptographic capability on top of it to be able to sell end-to-end verifiable supervised voting systems. So sort of take some of the core ideas that came from work that predated Star Vote, but were concretized in Star Vote, put a little different twist on it, and create a real open source product that is a crypto library for elections. So it's called Election Guard. My team designed and implemented the first version of it for Microsoft, working directly with the folks at Microsoft on the topic. And it has then flowered with a life of its own. It's seen multiple implementations in multiple programming languages by others. The verifier involved has been implemented multiple times by FFRDCs as well as private corporations. It's been available to the proprietary elections vendors of the world now for years with support for free. So any of them can take that technology stack and with a reasonable amount of resources, add it to their product to begin to sell an end-to-end verifiable supervised voting system.
That makes me feel better.
So that's a constructive thing, right? Now, of course, we're not going to get to use one of those until a jurisdiction or state actually publishes an RFP that says we want end-to-end verifiability. So now we're in a catch-22 because election systems are only procured on average every 10 years. And the existing vendors don't want to change what they want to do because they make a lot of money off of doing what they're doing today.
I like that line of reasoning. It's for me, it's not as doom and gloom as in you have to make the audience to realize that this is actually weird. There are weird things going on, and that we should and we must be concerned about those ideas, and that we, as citizens, should be pushing this kind of ideas forward, especially us that are in academia and that understand the depth of how weird these systems are. Going forward into the subject of looking into more the formality and how these things can be made more secure, I think an interesting line of story here is that I've noticed that you did your PhD in Caltech and in quite a formal methods type theory line of research. And how did you transition into making your career into secure voting, and how did that come about, and what are the problems that you've been working on?
Well, firstly, I'll say, yes, my PhD work is highly theoretical stuff, right? It's like category theory meets type theory meets algebras, etc. But it was all geared towards practicality. And it was really about how do we bring formal methods to the masses by hiding those formal methods and being able to build new tools that normal engineers can use. So like the last 25 years of my career has been about that. The theory stuff sits behind the scenes and is necessary, and somebody has to carry that load and enjoy that work. But you really want to hide that from almost every engineer and every end user. I will also say, voting accounts for like 5% of my work over the past 20 years. It's an important nationally critical system, but it's not the one that you make any money off of. In fact, you can barely get any money to do R&D on it at all. And so most of my work is on nationally critical infrastructure and national security problems for which people actually pay money and care about it. So, so the reason, the connection between the two worlds is if you're going to be the kind of person that focuses on high assurance systems engineering, right? You want to build systems that are demonstrably correct to third parties to the utmost level at the very edge of all capabilities, whether it's a software system or an ASIC or an FPGA or a giant distributed concurrent system. Then that means you need the appropriate tools and techniques and foundations so that you can actually describe what you're going to build it, and demonstrate that you conform to that specification. So the formal methods inherent, like in my PhD work and in papers published in the 90s, set us up for that kind of agenda so that you can have sort of a broad spectrum view on formal methods, and in particular on applied formal methods, so that you can use the right tools for the job for any particular problem. Now, some of the problems we tackle are sort of fairly straightforward in building a system that may only touch upon 2 or 3 different technical sub areas of computer science. Like, for example, the fully homomorphic accelerator that we recently taped out at Galois involves hardcore work in cryptography, and in particular, both normal crypto and in FHE, as well as hardware design with what we call rigorous digital engineering, because you need a proper threat model, you need a domain engineering model, you need requirements that you can transliterate into properties, etc. So it involved like 3 areas of computing brought together. Now, voting is interesting because it brings together far more than 3 areas. And in particular, it gives you a set of requirements on building a system to help out with elections that are seemingly contradictory. So it makes it really interesting as a domain area with regards to the translation of hairy, formalizations in Coq all the way to its realization in some system. Because in general, most voting systems, for one, involve more than just computers and digital inputs and outputs. They involve pieces of paper and they involve workflows with people. And so as soon as you have people in the loop, you have to worry about matters of accessibility, duplicitous actors, etc. So the threat model is really interesting because it spans all those artifacts. You have conformance to statutes and rules. So now you have an extra angle with regards to requirements and verifiability. You have federal standards about matters of accessibility that you have to pay attention to so that voters who are disabled have a means by which to independently vote. And then you have a whole question of certification. What does it mean to build a system that conforms to its specification, which largely is like in the Stone Age and they're banging rocks together compared to what we're capable of doing. And so it's fun to work in the topic where you can show that with the same amount of resources, you can do 1,000,000 times better than is out there in the field. And we just need to help the government raise the bar when it comes to correctness and security assurance of a system. So the reason, elections are interesting is because it brings together all those things in a way that's really tantalizing to a researcher or a practitioner in the field, because it rolls together, cryptography, software engineering, hardware engineering, systems engineering, reliability engineering, user-centric design, and accessibility all in one. And there's just not many projects that have all that in one sort of remit.
So let's start getting into like the details of this. I mean,
Sure.
One of the things that fascinates me about all this work in security is, I mean, you must have to rule out all these different side channels, which kind of by definition are things that aren't in your model or they're outside of what you considered. How do you reason about that? I can't conceive of it.
Well, historically, side channels were ignored in election systems. I mean, they were there, but people didn't talk about them. If you have public elections and everyone's standing in a room and sticking up their hand, that's a side channel, right? Because you're revealing to any adversary in the room how everyone is voting. There's additional and more subtle side channels that exist that people started to pay attention to even before computers being widely used. So, for example, a couple of other examples is when you go in to vote in a given jurisdiction based upon like your party preference, you might be handed a different ballot than other people next to you. But if you are like the lone voter or one of a few voters that gets handed a particular ballot style and they do a tabulation and they publish the outcome, well, now reliably there's a side channel leakage based upon how you voted because of the statistics involved in the tabulation and the transparency. Another example is historically disabled voters in America got to use a ballot marking device to facilitate their vote. But the ballot marking device would produce a ballot that has a different shape and nature than the votes written by normal people. And so now you have a side channel about how all your disabled voters are voting. And so it was always prolifically there, and only like the super security geeks really cared about it because they want everyone to have private votes. In anonymity, most elections officials didn't care, right? Because it was in the margins, and who cares if I'm going to accidentally leak a few ballots? But as you get more and more digital technology involved, and there's no attention to these matters as side channels, it got worse and worse. And now, for example, we have elections officials who are publishing, literally publishing scans of every ballot online after an election. And that is like a huge side channel. Because based upon how you mark, if you're an adversarial perspective, you can leak any information you want about any ballot. So how do you mitigate that? And so it's become a big thing. And therefore, all the modernized threat models around elections do pay attention to it. It's part of those threat models, and it's something that needs to be mitigated in the system that's built. And so it's started to roll into practice in certain kinds of federal requirements. And we will we have started to see some systems that attempt to mitigate these sorts of things. So, for example, if you use a ballot marking device, it marks the ballot in a way that looks like a normal person, and it has randomness involved and the like, so that it now decreases that side channel. Or you have people publishing ballots where they do an analysis of every ballot to see if there's any stray marks or anything that might leak information, and those are elided, and then you publish the ballot without that data. Or you do like a differential privacy sort of thing where you publish data sets, but you don't publish them in the clear and you only provide queries on them, like we've done for census. So there's a whole bunch of mitigations there that have been going on. But, you still have the problem of, if I'm going to vote from home on my device and people want internet voting, well, I'm at home. My abusive spouse could be standing next to me, or I'm, at my office and my boss can be standing next to me with $100 bill or a belt, and they can decide how I vote. So there's still a huge problem with side channels.
So does your spec, like, you go from like a cock proof and the cock tells you there might be an abusive spouse sitting next to them?
Yeah, literally.
Like, how do those connect?
You literally, so the threat models that we write, so if you think about this from a threat modeling perspective, the threat models that we write for any system, not just voting systems, are sort of precisely written English threat models that characterize your adversaries, their power, their control, their capability from a systems perspective and a cryptographic perspective. Then you turn that into a formal specification that gives you the hooks by which you can reason about the existence of adversaries and their strengths. So we actually do this with what's called a feature model, which is a certain kind of formalization that lets you talk about the features of a system or the anti-features of a system and how you're going to mitigate them. So it gives you kind of a binder for which you can reason about this. And then when you get to your full formal specification of your cryptographic protocol, for example, which is one of the places where this is mitigated, now you have those hooks that go all the way back to your threat model, so that as part of your crypto design and your security proof, you can refer directly to those adversaries and their activities. So, for example, some new work that I'm aware of and helping out a little bit on this front has to do with things like, so there's complaints from the community about ballot marking devices. In particular, the complaints are the ballot marking device is a computer acting on a voter's behalf to mark a piece of paper. Therefore, an adversary can be there, can watch the voter's behavior, and can do whatever it wants with that piece of paper. And moreover, the pieces of paper developed that are produced by these systems are both marked in the way that you would think it should be, right? So there's little black marks where they should be. But there's also a QR code which encodes that particular vote in a proprietary format in digital fashion. And when you tabulate, almost all these systems look at the QR code and ignore the marking. So you have this opacity here, which could both leak information as well as be a place where adversarial intent is baked. They can change the QR code any way they want. The vote can look correct to the voter, though most voters don't actually double check their ballot. And yet the adversary is putting whatever they want there. This means we need an adversarial model, which is both cryptographic and probabilistic, that puts the adversary directly in the voting system so that they can output anything they want on that piece of paper and in the digital record. So there's cryptographers actively working on this now to push the frontiers of our threat model into places where we didn't have them before, and we directly adopt that work in our mechanizations. So when we specify a system, its adversaries, its security model, and how it's mitigating those adversaries from a cryptographic perspective as well as a systems perspective, we're paying attention to that in exactly the same fashion.
Let's get more precise on the formalization of the system then. What kind of how does it look like, and how does formal methods and maybe type theory, these sort of ideas, may come along for help?
So if you look on Free and Fair's GitHub, you'll see almost everything we've ever done is open source. So I'll give you some examples of the kinds of things that we've done. And I can give you examples of what some other folks have done too. If we first look at other folks and how they've done some of these specification and reasoning about the necessary underpinnings to build these kinds of systems, you'll see things like occasional use of tools that permit you to specify and reason about cryptographic protocols. So you'll see occasional use of like Bruno's tools like ProVerif and CryptoVerif, Gilles' Gilles and team's work on EasyCrypt. You'll see occasionally direct encoding of protocol specification in Coq, and then using Greg's work on FCF to reason about security properties. You'll see occasional use of F* from Microsoft Research in order to specify and reason about a system. So it really varies depending upon the team at play and which tools they're familiar with about how they might encode these things. Now, that only talks about the crypto. It doesn't actually talk about like any of the distributed systems reasoning in occasions when you want assurance for that. In that setting, you'll see people use tools like, the TLA plus toolbox to specify the distributed system and reason about its properties like deadlock freedom and, liveness and similar. You might see people again use F* for this purpose, or some of the work that's spun out of it at Microsoft that's used to specify and reason about things like, TLS and similar. And again, it's the kind of place where you'll occasionally see people encode stuff directly in a logical framework based upon some underlying set of modules that give them the expressiveness they need to reason about at least a model of the system. Now, that work is very different from ours because for the most part, 99.9% of that work is about writing a formal model, reasoning about the model, and then they go off and write software with no documentation. And there's no connection between those two universes, right? That's prolific in this world of applied formal methods in the real world without being honest and not a little hypocritical about what you do. I think it's great. If you're going to go so far as to specify and reason about a protocol and then be very careful about implementing a system, like we have for Paxos that sits underneath Google Docs. It's great. It's not good enough for the world of elections. I can't just go off and write a giant pile of TypeScript nobody understands and claim it conforms to some specification in TLA. So what we do that's different is we always specify the components of the system using mechanical means in a fashion that facilitates actual formal verification of the software implementations, the hardware implementations, and the firmware implementations. So direct down to binaries like we do on other national security problems. So that means for the most part, the specifications we've written, say at Free and Fair, about elections related systems would be specified in things like Alloy for domain engineering models and top level election scheme specifications so that we can automatically derive through counterexamples end-to-end and integration tests for complex algorithms. We do a lot of specification in Coq so that we can reason about meta-theoretical properties of the algorithms and systems themselves, couple it to other systems, and then use extraction to generate implementations, which we can then reason about using other tools, is fairly common. So we mostly use Coq for that. We've used Lean a little bit for that in experiments, and we use Isabelle a little bit for that in experiments. And then we use Cryptol, for example, to specify our cryptographic algorithms in some facets of protocols so that we can use tools like SAW from Galois to reason about the correctness of implementations in accordance with those executable specifications. So that's sort of the gamut of typical tools that we use in our work, because we want to both reason about the models with regards to the requirements, and we want to reason about the implementations with regards to the models and the requirements. And on the requirements front, because we haven't talked about that at all, the place where we, if we have a situation where we have what I call semi-formal requirements that trickle down from the client or from statutes, et cetera, and we want to transliterate those into formal properties, we either do that by hand with peer review, and the peer review really grounds itself in making sure that any theorems stipulated in the requirements are transliterated into theorems into the formalism, and then you prove the theorems hold, so that gives you validity of your model. Or you use tools that actually help you do this. And the main tool we use there is called FRET, which comes from NASA, and it gives you what looks like a restricted version of English to write your specifications, and it automatically translates your requirements into LTL properties. about which you can then reason using other tools. And so there we do the exact same thing. We automatically translate it into LTL properties. Those are transliterated into, for example, Cryptol specs with theorems. We prove those theorems hold for the model. So therefore, we've proven that the model conforms to the requirements. And then we handwrite or automatically generate an implementation from Cryptol and prove that the implementation conforms to that model. So you get full traceability and full transitive correctness all the way up to your ConOps and your specifications. So you'll see a number of election systems that we've written, both a risk limiting audit system and a tabulator, do exactly what I just described. And we did those with IRAD dollars for fun to show the world that this can be done. And we shouldn't be accepting giant black boxes stuffed with, undocumented JavaScript and giant piles of C++ nobody understands. So that's a bit in the weeds to give you a feel for the kinds of the rigor that we impose upon ourselves.
Please, let's stay in the weeds. I love this. I was thinking to ask then, like, what are there like specific things that you guys want out of Coq, for example, or out of Haskell that makes this type of work easier, or is it just vanilla stuff?
Yeah, there's specific things that make it easier, and some of these specific things have seen some work over the past few years, especially when it comes to matters of automated reasoning or facilitated automated reasoning, and then connections between reasoning and implementations. So the first thing that is necessary in our perspective is the ability to write literate specifications. So I need to be able to, in a Knuth sort of fashion, I need to be able to write English or other natural languages adjacent to mechanized formal specifications. So in general, most of the specs that you see from us will literally take a normal English document written by experts in the field, for example, a NIST specification of a cryptographic algorithm, and we will make them literate by virtue of weaving into them the mechanized specs. So now the document is both like an RFC-like thing or a local government standard, and it's consumable by tools to reason about its type correctness, its well-formedness, its meta-theoretical properties, and then used as a foundation for verification. So literate specs is mandatory. And happily, we already have literate specs in all the logical frameworks, and we already have literate specification support in Cryptol. We don't have literate specification support in some of the other tools that we use with which to reason about cryptographic protocols in particular. So that's element one. Element two is facilitated reasoning. So of course, right now we have strategies and tactics and similar or rewrite systems in various tools that give us some degree of automation when it comes to reasoning about these systems. But oftentimes that's insufficient and too domain generic to really help you write some of these most complex specifications and get them done with efficacy. So for example, you'll note that no one has mechanized and reasoned about, to my knowledge, the entire star vote protocol in any of these tools. It's too hard. With the degree of automation that we have at hand, nobody's willing to spend the man years necessary in order to do that because the automation just hasn't gotten good enough. Maybe with what we've seen in Lean, especially with Lean 4, combined with the R&D we and others are doing on generative AI in doing proof generation and proof repair, we'll get there. But it's really, really hard. And then the third thing is extraction. If I'm going to extract an implementation from a specification, it needs to be usable by a normal human being, and it needs to come with assurance out of the box that has nothing to do with the original specification. I need to be using real verification tools to reason about the theorems inherent in the original spec, about the real software or about the real hardware. And most of the tools that provide for extraction don't target programming languages for which there's verification tools. So we're just stuck, right? I mean, I can extract Haskell or OCaml and then I'm fucked, pardon me. But, it's like there's just no tools that let me do the kind of high assurance reasoning I can do. And while there's some new capability in like generating, like extracting C code from Coq or Rock, I should say, and or extracting more mainstream languages from Lean, the code that's extracted is not reasonable. It's not the kind of thing that I can just apply a normal off-the-shelf research or commercial reasoning tool about. So all the work we've done on, for example, extraction from Cryptol focuses on exactly this. I want to generate from Cryptol, and I do generate from Cryptol, high performance, formally verifiable implementations out of the box for which I can immediately reason about their correctness with regards to their specifications. We need more of that. I need to be able to do that from Rock in particular. Like if I had a backend on Rock that would let me generate either or both the subset of formally verifiable minimal C for as much as I hold my nose and I have to deal with it, and then I were able to use some of the common tools we use to reason about C out of the box, that would be great. It wouldn't be acceptable to the government because they won't permit us to, I won't say this. They're moving towards a realm where they're not going to permit us to use C anymore. But having that would be great. Or better yet, let's target Rust. Extract Rust that already has formal specifications in it for which I can use the best tools, which still aren't great, but are at least better than they used to be, so that I can reason about that Rust. So the ability to use out of the box Iris and Varus and Crux and other tools that we're building that let us, like the new backend on SAW that lets me reason about Rust, that would be fantastic. Let's actually extract the languages that people care about, not languages for which programming languages people care about, because those are two different things.
That is awesome. I'm really happy that you guys are working so hard in all of this. We are starting to run a little short on time. How about we start wrapping things up on some kind of story that you have found some kind of flaw in your models and how you managed that and how did formal methods helped you with it?
Okay, we can do that. So my work where formal methods are applied comes in two forms. Either you use these tools to build something new and from scratch, maybe reusing some things that you already have that have some degree of assurance, or you analyze someone else's system and you're using formal methods to find problems with somebody else's system. So both these things are quite effective. In those circumstances where we're being constructive and we're turning what amounts to requirements and statutes into formality and then systems, the formal methods really helped us discover and attend to inconsistencies and contradictions in or vagueness in the original requirements and statutes. That happens time and time again. Every time we look at a complicated RFP or set of statutes and you mechanize it in any fashion, you end up having to deal with the underspecifications that are inherent in the English written by some legislatures or some good intending people helping write something. So the formal methods helped us catch those problems before we get anywhere near the implementation and make sure that the system we're building actually is realizable and has a consistent specification that is complete, because these tools help you reason about those meta-theoretical properties before you get anywhere near an implementation. That's on the constructive point. So it helps me make sure that the system I'm building is the right system the first time. And in fact, if you use verification as you build the system, so as you either generate code or write code in conformance to the spec, that means literally when you finish writing main, at the very end, the system runs right the first time, is mostly what happens in these circumstances. And if it doesn't, it usually drives back to some subtlety of environment, some problem with the hardware you're baked on, or some sort of assumption that you've made wasn't strong enough because it didn't capture the real world as present. Now, when you're looking at somebody else's system, what you're frequently faced with there is lifting a model from what they've done, because they didn't have any of this to begin with. So you often end up either staring at code or staring at statutes or RFPs they originally started from and writing even a partial, rigorous model of what the system's meant to do. We call this contracting the design instead of design by contract, which is the other thing that we do. And then you use that particular mechanization as a means by which to inspect what they've done, either through runtime verification, through the generation of inputs to check that the outputs from the system conform to the model, or through static verification, literally doing things like extended static checking of implementations at the source level, or attempted formal verification at the source or binary level. And there, what we find time and time again is because they didn't use the rigor to get from the highest level specs down to an implementation. Like typically they have an Excel spreadsheet with 1,000 requirements and then a pile of undocumented code and nothing in between. You find that nothing is right. Like every property you try to check is inherently not correct with regards to the system, even for the simplest things like tabulating correctly. And then you just end up with a mess. I mean, every system we look at in this fashion, when it comes to architectural properties, security properties, and correctness properties, even at the micro scale, it's just an awful mess. So an example of this was a tabulator used in Ireland. A proprietary company built a black box tabulator to count votes in Ireland many years ago. And I won't go into the politics of it, but let's just suffice to say there was shenanigans there too. And we were tasked with analyzing that black box tabulator to see whether or not it actually counted correctly. And so we went through an exercise, some colleagues with my input built a model to describe what tabulation should mean, and then use that model through counterexample generation to generate inputs. And then we're literally not permitted to do anything but run the black box system. And yet they found that it tabulated incorrectly. So you're not even using the most powerful tools at your disposal. You're dealing with a black box system for which you're sort of divining its abstract state machine and its behavior, and yet it was wrong. And this is like one of 100 examples of when you look at systems in the real world with this degree of rigor, especially in places where it's complicated and it's a national security problem, as it were, people never get it right because they just don't treat it that way. They treat it like an IT consultancy project where they're going to take some requirements they didn't understand and whack together something that's proprietary, closed source, undocumented, and barely tested. That's just how the world works.
What a beautiful way to end it.
There's more to say, but that is the tip of a gigantic iceberg. And I encourage any listener can go out and go with sufficient Googling and go find some leaked proprietary code from a voting system that's in the field today and be shocked at what you see. The piles of Visual Basic and undocumented C++ code and Java code that is over-engineered and unreasonable in a strict sense is just remarkable.
Well, with that high note, then I think this is a great place to finish things. Is that any closing remarks on any of your two parts?
I will say one thing I mentioned it before as a constructive way forward, but I didn't say anything more about it. Star vote is like the right answer for supervised voting. There are people working constructively on the right answer for internet voting too, though it's a smaller community because most researchers kind of want to stay away from it. It's a hot topic. It's extremely hard. It's extremely interesting. I helped write a whole book about it a number of years called that Future of Voting Report. So there are some people leaning into that and trying to do something good, though, of course, everyone looks at them as being potentially evil. The two folks that have invested in this over the past few years with whom I've worked have been both DARPA. So there's a DARPA project running on this topic right now, being executed by my friends at Voting Works, which is a nonprofit in California, which is doing some work based upon some of the work I've done in the past. And then a nonprofit called Tusk Philanthropies that's been trying to move forward ideas around mobile phone-based voting for low-valued elections and primaries for a number of years. And they're trying to be constructive about it. And we've been working with them on what are really good next steps on that front, attending to exactly what you and I are talking about here. Like literally, there's discussions going on now about an entire book that is the Cryptographic Foundations for All Voting, which is written by a friend of mine, and turning that into a literate document that has a mechanized spec of the entire cryptographic foundations for in-and verifiable voting. If they decide to do that with us, it'll be an enormous step forward for everybody, because it'll be a public outcome that everyone can leverage and everyone can begin to use for building trustworthy systems, whether they're doing something simple like runtime verification against the model, or whether they're doing full functional verification.
That is absolutely beautiful. And I'm sure that our listeners learned a lot. Dan right now is giving the motion of a mic drop. It was a perfect way
We're trying to do good
things.
We're trying to do good things, but it's hard. I just wish the government stepped up and actually invested in this more. I mean, to have a DARPA program focused on this problem is like, it's their job. But because of the politics involved and because I haven't yet said yes to being a program manager, it hasn't happened.
We are all very glad that are amazing people like you doing this kind of work, and this is very important stuff, as you have mentioned. That of course wraps up all the exciting parts of computer science. So thank you so much for your work. Thank you so much for your time, for being here. We will be in a conversation, see if we can find a time to continue this in a different time. So thank you so much for coming. Thanks, Dan, for your presence as well.
Thanks, Dan. Thanks for your good questions. I always enjoy talking about these kinds of things.
So that's it for today's episode. Thank you so much for everyone who stayed with us this far. I learned so much with Joe. I hope you guys also learn as much as I did. This was a much shorter episode. I usually like to go for longer, give more time for everyone to develop their ideas. But today was one-off event because Joe is such a busy person that he had another meeting to attend. So I'm actually just very glad that we had the opportunity to be here and to have this conversation with him. If you guys have any questions, please submit them to our email, typetirforall@gmail.com. If you like this episode, please send them to a close friend that you have. I'm sure that other people will also enjoy them. We're in this growth phase. Please also consider showing your support to the show. We have a Ko-Fi platform. Go to our website, typetirforall.com. and follow the prompts. You can donate any amount. As many of you know from the last episode, I already made this clear. I'm currently unemployed as I have finished my master's. If you guys can donate any amount, I will greatly appreciate. Well, I think that's it. Thank you so much for enjoying this show. Don't forget to also join our Discord, follow our Twitter, all those good stuff in our website. Keep up the good work, everyone. See you guys next time.